Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organizations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Welcome to the episode, everybody. I'm joined today by Vytenis Buzas, CEO and co-founder of NanoAvionics. NanoAvionics is a full-service nanosatellite mission integrator based in Columbia, Illinois, in the USA, with facilities also in North America, Europe, and the UK. NanoAvionics is a satsearch membership company and also manufactures nanosatellite buses with standardized configurations, along with various other subsystems developed in-house. So good morning, Vytenis, and welcome to the podcast.
Good morning, Howell. Good morning, colleagues. Thank you.
Great, thanks. So today I'd like to discuss with you a bit about agile manufacturing in nanosatellite production. Now, since the real growth of the commercial space sector began, we've seen various companies who are planning to deliver nanosatellite-based services very often choose to produce their own satellites in-house, mainly due to lead times in the industry being large and difficult to control for, particularly against price and particularly in high volumes. So in order for subsystem manufacturers and mission integrators in the wider supply chain to offer a better option than complete in-house production for these companies, agile manufacturing has been talked about as a solution. It helps achieve, greater speed and flexibility whilst respecting the quality and cost that such upstream clients require. Agile manufacturing is maybe a bit of a new concept to many in the industry and something that new space companies are trying to understand and grapple with. So I just wondered if you could share with us what agile manufacturing for nanosatellites means from your perspective.
The manufacturing by itself in the world of nanosatellites doesn't cover that big part as, for example, in general industry, like consumer electronics, for example. But I would rather emphasize that it's not like manufacturing alone is agile in this, let's say, nanosatellite or small satellite world, but entire system of manufacturing is more or less should be agile because there are various components, let's say, through the process which contribute to the final result, to the final hardware, right, of the satellite. And a lot of things should be harmonized in order to make, let's say, the satellite bus manufacturable, fast manufacturable. I mean, the design modular, for example, and to increase the quality, to increase the speed of the production, to decrease the price, etc. So there are a lot of things in this process, and of course, finally, quality assurance and quality requirements are growing through the year higher and higher. So while organizing the manufacturing as a process, it's a pretty broad thing in general. So we can try during our conversation to break it down, let's say, that process. I mean, whichever way you would like, but from this perspective, there is no kind of, single or simplified answer to describe the agility of manufacturing the nanosatellite.
Sure. Space technology is always complicated. There's the whole system of systems concept, which makes agility a discussion that needs to be performed at a certain level. So maybe we could start with one of the principles of agile manufacturing there, the problem of the customer order cycle. We've seen in space a bit of a pressure from upstream clients where customers are willing or expecting to wait less and less time, shorter and shorter timescales for the subsystems to be delivered or services to be carried out. So over the last few years, is there anything you've observed in the market with respect to order cycles let's substantiate agile manufacturing processes?
We observed quite an interesting thing. I remember when we just started this business, it was like around 2008 or so more than 10 years ago. People, of course, were betting a lot on the CubeSats. I mean, those satellites back in the days were called CubeSats. Now we try to call them nanosats and nanosatellites because we constantly increase the quality, constantly increase the functionality of those. So let's say quite a lot of the customers are still overestimating a little bit the current technology of the nanosatellite in general, and they expect a bit more than those nanosatellites can deliver as of today, of course. But bearing what is perception of the nanosatellite functionalities or capabilities of today, and comparing it with that what was 10 years ago, it becomes really different. And of course, people start to understand that nanosatellite by itself is a little bit limited machine because it follows the standard. I mean, the external like volume surface, right? And people start to realize, which is positive thing, and they start to adjust their payload instruments. So so those payload instruments can be accommodated from the various perspective. I'm not talking here about the volume alone or the mass. There are a lot of things. I mean, thermal, data interfaces, power interfaces, and a lot of other things. So the general trend, I mean, things are getting better. The customer becomes more and more aware of the limitations of the nanosatellite. And through this, you can develop and discover new opportunities and capabilities. So, discovering the limitation is not necessarily have to be a bad thing, right? Then you start to realize, the boundaries. You start to realize how you can extend your, let's say, functionality or capabilities within those boundaries. So it's an interesting process, actually. We observe since around 2010, roughly.
Right, interesting. And I think that concept of discovering the limitations and the boundaries also applies in the manufacturing process itself. Because although modularization and more common interfaces exist, there are certain tasks which still have to be done manually, or at the moment at least, such as populating boards and soldering. These are widely practiced in the space industry. They help engineers ensure reliability and carry out qualification ongoing, but there also could be argued to be bottlenecks in the ability to be fully agile. How do you think what is possible to tackle such manual processes or approach them?
Yeah, you're right. You cannot avoid manual processes entirely. This is correct because, let's say, one thing is we try to make the capex optimal, right? We don't want to invest too much into soldering machines, reflow machines, etc. Even though we can call our manufacturing like small series manufacturing, but it means like how much? Up to 100 pieces per year. It means that owning those machines in house doesn't make too much of economic sense. So we have to work a lot with our providers, suppliers, third parties, right? And but still you cannot avoid some manual operations in house. For example, you do not want to reveal bill of materials at full scope, right? Because you don't want to let know your suppliers, let's say, the most critical components. So you want to protect your AP, you want to protect your know-how. So you still have to do quite a few of the operations in-house. In most of the cases, yes, it is related with the final integration, inspection, soldering or assembling the most critical components or the most sensitive. And how we are dealing with this, of course, we are trying to implement, even though the relative turnover of the pieces of the units of the components in the entire industry is not that high comparing with other industries, right? We still want to organize it as much as possible as it would be broader series manufacturing market. So we can spare a lot of time. We can make things working much better, optimal, etc. So we try to combine. We always try to play with between custom manufacturing, where we need to tweak something for certain customers, and where we need to have a baseline product. I don't want to use the word standard product. It's like a baseline product. So how we do organize this in our case, we try to keep it modular, but not only the product by itself modular, like software, hardware modular, where you can stack up different modules with different functions. But we want to keep the manufacturing, let's say, chain or organizational modular as much as possible as well. So, for example, we design the hardware in a way that 80%, roughly 80%, for all of the customers, non-depending what is their payload instrument, we keep that hardware like a baseline, right? Always the same. So let's say 80% or even more is always the same. And we tweak the entire 20% where we adjust, let's say, I don't know, roughly telling interconnect jumpers in a different way, some resistors there, some resistors there, here. And also we are trying to solve as much things through the software and firmware as much as possible. So this is how we address this ourselves, and this is how we want to make those products we manufacture as much, look-alike, serious manufacturing as much as possible, even though it's like tens or, I don't know, couple of hundreds of pieces per year.
Right, excellent. So although there are those manual elements to the production of each system, they're limited to a certain percentage of the overall system, and they are necessary, as you've mentioned, for different reasons.
Yeah, I mean, we want to kind of isolate them as much as possible. I mean, we want to make them as firm as possible, and where things can be done by a machine, we want machines doing them, because they do not have emotions, they do not do that much mistakes as we does, right? As we do. So we want to very, very strictly isolate where is the job intended to be made by a machine, where is the job intended to be made by a human.
I think when a lot of people think about agile manufacturing in with nanosatellites, they see the core drivers as being the constellations that we've seen. As you mentioned, you have systems that are 80% consistent and 20% adapted. Sometimes there are plenty of constellations out there where each satellite is 100%, the same. So that's quite a well understood topic, and I think it's been spoken about a few times in the industry. I wonder whether you thought there were other segments, such as the in-orbit demonstrations or verifications missions, or even scientific research missions, which have or could have the same expectations of agile manufacturing.
The interesting thing in general is that nanosatellite industry is becoming more and more mature. Even though, let's say, people have, not all of the companies or people are talking about the constellations, right? As you just mentioned. Some of them are talking about the one-off IOD missions or one-off scientific missions, etc. But the interesting thing is they expect, and the expectations in general are becoming, more and more industrial grade, right? So if, let's say, people 10 years ago were thinking that the CubeSat is kind of expandable machine, right? You just load it with a bunch of batteries. It works for 1 week, and that's it, right? It decays. It burns in the atmosphere. So now people are thinking differently. They're thinking that this is an industrial machine, and it have to last. If it is being built once, if it is being launched once, it have to last, and it have to work. And the software technologies and the firmware technologies are becoming more and more capable. So even with the same hardware, you can start doing a lot of different things. You can reprogram the satellite, you can test different algorithms, etc. So it was different 10 years ago. You just you flash the satellite once, and that's it. You cannot do anything. And but where people started to implement in-orbit firmware flash function, it changed the game significantly. It started to look like more like a mobile phone. You have the same set of hardware. Let's say you use that set of hardware for how much? 1 year, maximum 2 years. But during that period, the firmware is being updated a lot of times. I mean, dozens of times. And after that 1 year or 2 years, you sometimes start feeling even like, you have a different set of the hardware because some different capabilities or some, let's say, optimizations are being made during that period. So even your hardware can start working, how to say, faster, roughly telling, or the batteries can last longer because some processes are being optimized.
Then when it comes to the size of the satellites out there, in the CubeSat form factor, you can go from 1U to 27U, with a decent amount of from different areas. However, that's a vastly different satellite, even with modular systems and common interfaces, etc. So how do you go about looking at scaling agile processes for larger subsystems to those larger satellite form factors?
Yeah, very interesting topic for the discussion, actually. So we seek, and well, most of our competitors are always seeking to supply the constellation, right, for that golden customer, so to say. And we all of us realize that we cannot suddenly change the processes, procedures. Let's say now we manufacture like 20 pieces of the satellites per year. If suddenly a customer is coming and asking, hey, now you're going to manufacture like 50 or 100 pieces per year for me, like in upcoming 3 years. So we cannot just suddenly, upgrade the manufacturing procedures or, entire infrastructure to accommodate this kind of the numbers. So we constantly think how we have to build things today that tomorrow the same infrastructure can accommodate 3-4 times increased manufacturing capabilities, but at the same time not spending too much of capex. While let's say today we are manufacturing 10 satellites, and if we think how we can do increase the manufacturing capabilities, let's say within the same infrastructure, and manufacture 40 or 30 satellites per year without significantly investing into the infrastructure. Because even if we could, let's say, every time to invest some additional cash into that infrastructure, it will take half a year realistically to align everything. It doesn't happen, during the weekend, right? During a couple of days. So from this perspective, I mean, we are always thinking today we manufacture a couple of dozen satellites per year, but we're always thinking how we are going to manufacture, well, hundreds of the satellites when that customer will come. And let's say current customers who are working with us on various applications, they are always talking that they are going to scale their constellations. Of course, many of them will fail, but some of them will reach their goals. So having in mind everything, all of this, we're organizing and building the infrastructure so we can accommodate the future demand.
Excellent. So that agility is the potential to achieve that agility and higher volume is built in from the very start. What about in terms of technical factors when comes to this specific technology? Are there any factors that involve volatility? Thinking of things like interface requirements, special AOCS systems or communications that make it difficult to accommodate certain payloads, which therefore apply a bit of a constraint on the ability to be agile.
I should say roughly that 70 or 80% of the customers can use pretty much the same vehicle. I mean, everyone. Like it's like I don't know, a basis of the car, and the same car can be an ambulance. The same car can be accommodate firefighting equipment, etc. So the basis of the car is the same. You just have to tweak, a small part of that. In some cases, of course, you have to go a bit more extremely beyond those boundaries. So then, of course, the project becomes a bit more expensive. It will take a bit longer to implement everything. But from the perspective of our company, we always seek, to have as much baseline as possible. Of course, you cannot do it too much because if you will try to do, like universal things, universal machines, it means that at some point you will start narrowing down the ability to serve different kind of the customers, because all of them are very, very different. I mean, starting with earth observation and finishing with telecommunication. I mean, the problems the satellite bus needs to handle are completely different. I mean, one needs more power, another one needs more thermal stability, another one needs, like very accurate ADCS, etc. So at this point, we do reserve some room for those, to accommodate different customers. I mean, we do reserve some margin in terms of technical capabilities, in terms of simply the volume, right, or the mass. But yeah, you cannot accommodate everything all the time. So in some of the cases, of course, you have to tweak and you have to go beyond those boundaries. So, but yeah, there is a price of that.
So it's very much about balancing the trade-offs that you have to make.
Exactly. I mean, if it becomes too far from what we can offer, it means maybe that payload even cannot be flown with a nano satellite, for example. But again, I mean, while we're talking about that, for this reason, we see that our customers are pushing beyond those boundaries quite often. So that's why, last week we introduced our 100 kg bus, because today we have 6, 12, 16 units, right, which can be launched as a nano satellites from the deployer. But if we go beyond 16 units, right, if we go beyond like a roughly 30 kgs, then we have to think about the separation rings. And for that reason, we introduced to the market separation ring deployed bus.
Serving new markets has also led you to develop new innovation, which is the way around you want to do it, right? Create the product for the demand. It's so, and I think another aspect of agile manufacturing, you touched on this briefly earlier, talking about the, IP protection and how you deal with your own suppliers. Presumably, the drive to be agile has required you to add sort of levels of sophistication to your own supply chain, with different tiers of suppliers supporting you in different ways with materials, components, etc. How have you found this process? How are space industry suppliers able to serve you, keep up with the requirements that agile manufacturing might put on them in turn?
Very interesting topic for the discussion. I mean, but observe actually quite a few of the problems in the supply chain. And we always try to diversify our suppliers, because some of the customers are very demanding. I mean, they come to us, they run the audit, couple of days, they just, digging deep into our abilities to ensure quality, etc. And in some of the cases, I mean, some suppliers, they, I don't know how to explain, but they lost a momentum a little bit to keep up with the market. The market demand and the market requirements, and especially expectations for quality, okay. I mean, onboard power resources and in general onboard resources and functionality are growing much faster than, I don't know, 70, 60% of the regular or typical suppliers, or typical, let's say, there are some suppliers who are not that broad in what they offer. I mean, maybe they offer some very narrow, like, payload controllers, right? Or onboard computers, or ADCS systems, or even some sensors. For those guys, maybe it is more difficult to develop a feeling where the market is going, and, to have that information where it is going. And yeah, we had some difficulties historically with a couple of good or respected suppliers where they didn't, cannot keep up with the growing expectations of the market. So this is actually interesting. And the interesting thing that in some of the cases we were kind of forced to switch the supplier, or even we were forced to develop that particular component for ourselves. But overall, nano satellite market is very young. I mean, it's 20 years. So from the industrial perspective, it's like baby who even cannot walk on her, two legs, right? So it still crawls on arms and legs. So in general, yes, the maturity of the market overall is a bit early, so to say. And there are a lot of processes. We observe a lot of processes. Now in the market where some consolidation is happening. Bigger companies are acquiring smaller companies. Big investments are coming, and a lot of things are happening. And this is the result of the market becoming more mature.
Yeah, and I think you're right. The analogy is perfectly right, and I think these are growing pains, right? You can imagine for some of these suppliers of the types of components and materials and things that you mentioned have had to deal with pressures on them over years past that have been wildly different to what they have today. It's very different to serve a commercial constellation manufacturer than it is to provide a few units for an ESA mission. Different timescales, different requirements on on quality, on sharing information, all that sort of thing. So it's interesting. You're right in the middle dealing with these problems today. And I guess to bring that back to some of the aspects of agile manufacturing, those problems often are often realized in the results of testing processes. And alongside speeding and scaling up manufacturing, have you also found it necessary to find ways of making testing quicker?
We constantly work to make the testing processes automatic as much as possible, because there are, of course, the hardware is becoming more and more complex, meaning it can accommodate more and more functions, different functions, and then different combinations of the functions. So in general, the different aspects, there are like huge numbers of different aspects. Those are still not infinite, right? But there are like, I don't know, thousands of different combinations in the functionality, and thousands of, or tens of thousands, or even more of situations where something can go wrong. And yes, we're also always thinking about the making the testing processes automatic. For example, we have implemented, I don't know, since the very early days of the company, we have implemented the capability for our customer to test their payload like virtually. So for example, we assemble hardware in house, we put it in the server rack, roughly telling, and through the internet, through TCP, our customer can interconnect with that hardware. Simulated satellite as a piece of hardware. They can interconnect it with their payload instrument, and they can start developing the software like right after we sign the contract. So through these processes, of course, through this capability, once established, we started to think how we can improve it. So we started to feed that hardware within inputs, for example, from simulated environment, or even from the actual environment. We feed it with a satellite telemetry of the satellites which are flying today in orbit, so our customer can test various combinations. This is, let's say, the process of the development. But we started to apply the same or similar principles to the testing, right? Where we test the hardware, we test the satellite simulating the actual natural environment as much as possible. Another one thing, we just test the functions automatically, because there are thousands of them. So yes, we do these things, and of course, it is being implemented mostly through the software, and the process is more and more standardized. All of the different satellites contain 80% of very similar functions: power generation, attitude control, determination, navigation, etc. Of course, some of the things should be like observed or monitored manually by human, but we constantly increase the factor of automation in this kind of the process. In the process of testing.
We looked at some of the different areas there of agile manufacturing over the course of discussion so far. The testing, your own downstream supply chain, obviously the your actual manufacturing processes and technical production. Another area where your own activities interface with the wider industry where Agile could, be to have an effect is the launch and the ground segment parts of the industry. Are those areas, are launch and ground segments, meeting your expectations? Are they developing in a way that enables other parts of the industry to be more agile and speed up?
Yeah, I mean, I'm very, very happy about the launch industry. It helped, very simply and roughly telling, through the last 10 years, the price has decreased 10 times, right? Roughly 8 to 10 times. Like 10 years ago, the launch it's by itself was a major bottleneck. I mean, to launch 1 kg for 100,000 euros, it was really crazy thing. I mean, so it only a few organizations, worldwide, 15 or 10 years ago, were able to allow themselves to afford to launch a CubeSat. But today, what we see, I mean, today we see the price went down like 8, 10 times, and it created a lot of capabilities. And it's a very good thing because it accelerates the growth of the market and the maturization of the market really, really significantly. And this is a good thing, actually. And through the increased capabilities to launch hardware into orbit, the market looks more and more as an industrial environment. I mean, real industrial environment, real economy. So I'm very happy about that. And more and more, those theoretical principles which are applied for general economy, they can be applied within the nano satellite and small satellite industry. So it's a very big and huge and very good thing that launchers market is growing and getting significantly stronger than it was 10 years ago. The ground segment, it's interesting. Our hardware, our satellites are compatible with, most popular ground station providers, right? Ground station network providers. So one of the major partners we have is KSAT, and we work with KSAT for quite a few years. A couple of programs were funded by European Commission, European Space Agency, where we enabled nano satellites to be compatible with KSAT, for example. So again, working on various bands, S-band, UHF, K-band, for example. So we are very happy about that. And of course, it took some effort to make nano satellites compatible with those professional ground station networks, but it is paying off. I mean, we have global access, like literally global access. Of course, there are some, blind spots above the oceans, above the deserts, but we're working with the partners on inter-satellite link. I mean, LEO to LEO, and then LEO to GEO, and then to Earth. So yeah, those projects were also funded by European Space Agency and European Commission. But talking about the mission control software, which combines everything and which enables everything to work as a unified, end-to-end solution, we also tested few things, but this is something what we do ourselves. I mean, we need something specialized for nanosatellite demands. We need something specialized for so-called mega constellations, where we launch, beyond tens or dozens of the satellites. I mean, we're thinking here about the few hundreds or a couple of hundreds of satellites. So we found it a bit difficult to buy some, developed systems and, reapply them on top of the nanosatellite world we cover. So we are developing something by ourselves. I mean, talking about the mission control software, because mission control from the broader perspective was implemented only on the satellites, bigger satellites, like, a few hundred kg buses like Kinmersat, like Globalstar, Orbcom, etc. So, or then we have professional mission control tools where we're talking about geostationary. But for nanosatellites, something which can work professionally, there was some kind of gap we indicated a few years ago, and now we have our own mission control system. Again, it's modular. We can, increase or decrease the number of the modules which are, solving different kinds of the problems for the satellite at the local extent or the global extent for the constellation. Yeah, but for this, we developed something our own.
Ah, interesting. Okay, so just to take a little bit of a step back and talk about agile manufacturing in general, I think a lot of people use the example of the automotive industry when we're looking at industrial processes, and one of the flagship concepts there is just-in-time manufacturing. Do you see any scope to apply concepts such as that to the production of nanosatellites in order to remove inventory, free up space, etc.?
We try to apply some principles which are coming from automotive industry. We try to do, let's say, or to narrow down the operations being done by a single, single sub-organization or single person or single supplier. So again, everything is being more transparent. We decrease the space for improvisation, which is pretty harmful thing, as we learned in the past. So we try to apply, these kind of the principles in order to track, manufacturing, to make it leaner, to make it more agile, etc. So, of course, nanosatellite industry is not really well comparable with the automotive industry because of the, amounts, because of the simple standardization, literally standardization. But still, I mean, at least locally within the level of the company, we look how things are being organized in automotive industry. We look how things are being even organized in medical industry, for example. Yeah, because of the requirements. Because again, we represent nanosatellite industry. It's not old space, right? Where we spend millions for testing, for quality assurance. But it's not CubeSats where we put, I don't know, a dozen of batteries in the small box. We launch it and we are still happy even if it's not working, right? So we are something in between, which is called, I don't know, maybe the term is getting cold. I mean, new space, but we're building nanosatellites, which is something in between the old space and that student approach, but still balanced, economically, not too expensive in testing, but functional and reliable enough to satisfy more and more demanding customer.
Right, interesting examples there of other industries using. I understand the medical example on reflection, highly regulated. Compliance so important. The failure is very much something you want to avoid, and yeah, interesting. Okay, so and then you mentioned the industrialization and the commercial aspect of it, and I think in these other industries, automotive, etc., there's wide use of commercial off-the-shelf parts and components, COTS components, and these are one way to shorten manufacturing times and reduce costs, but they can come with at least a perception of a trade-off in terms of performance and possibly reliability, which is so important as you get to increase satellite sizes and mission lifetimes. So how do you approach the use of commercial off-the-shelf components in nanoavionics? Are they widely used or not so much?
They are very widely used. So in most of the cases, we apply, well, so to say, highest grade industrial components. These are not that high as medical grade components or military grade components, right? Or old space grade components, where they really, I mean, microcontrollers cost like tens of thousands of euros. I mean, in this case, nanosatellite industry wouldn't exist at all if we would need, to use this kind of the components. But in general, a highest grade industrial components in most of the cases means that these are automotive grade components. I mean, automotive grade components are really high grade components, and in the context of the today's environment, I mean, in the automotive industry, things need to be reliable, right? Because it directly translates into the health problems or even, life and death question. So automotive grade components are really well applicable in the nanosatellite world. In some of the cases, of course, we do buy medical grade components, which are still not that expensive, as military or old space style components. But we do, certain levels of inspections, incoming inspections for certain type of the components. If these are active components or, semiconductor components, the inspection is more strict. If it's passive components like capacitors, resistors, roughly telling, maybe it's not that much strict. But still, we do incoming inspection. We want to put it on the shoulders of our suppliers as much as possible, because our suppliers in most of the cases are, well, mainstream industry or consumer industry suppliers, so they do a lot of things, and they have a huge how would say level of automation implemented. So we always try to do as less tasks as possible. So we involve minimal amount of the human, and then we avoid maximum mistakes possibly made. So yeah, but still, I mean, incoming, outgoing inspections, especially, I mean, if these are components, if we are talking about the subsystems which are being purchased and reused within our buses we build. So then we have also some environmental kind of qualification or testing to make sure that that component will not cause any problem to the rest of the system. So yes, these operations are implemented, and we see that we cannot go without them.
And I think a lot of this all boils down to speed, which we've mentioned a few times, the speed for the customer. And if we sort of put aside, costs, reliability, risk, quality, and assume all those things are kind of equal, I was wondering, in your view, how you thought how short the overall cycle of a satellite project could be from kickoff to on orbit service operational. What could we achieve?
So the shortest we had was like 2.5 months.
Wow.
So roughly telling 10 weeks. But of course, this is extremum. This is crazy. People need to work in 2 shifts. Very important customer. I mean, we can do it once in a while, but I mean, when you work under pressure, a probability to make some mistakes increases like tenfold. I mean, this is statistics. Like, people under pressure tend to make 11 times more mistakes as they're working, during normal conditions. But I should say nominal, comfortable period of manufacturing the regular bus we have is like 6 months, for example. Roughly telling, right? 5 to 7, 6, let's say, is kind of now a sweet spot, combining, risks, price, manufacturing. Let's say, again, you have to simply give some time for components to arrive to your place of the integration. So combining everything, I mean, logistics and everything, 6 months is something which sounds like a regular thing.
Yeah, and presumably taking into account global pandemics.
Yes. So of course, last spring was much harder,
Yeah, yeah.
where people didn't knew what to expect. But let's say this spring, again, at least in my region where I'm located right now, they reintroduced kind of strict lockdowns, in some places. But people, discovered how to work under these kind of the circumstances.
A cadence of 6 months and expectations that upstream clients can plan to, and I think that's some, like you say, everything in the industry has got, well, a lot of things in the industry have got cheaper, and many things have got faster. And I think these are results that would be very impressive to somebody 10 years ago.
Correct. Typical nano satellite, or back in the days, CubeSat project was like, people were assuming this is 2 years project.
That's fascinating. This shows how far we've come. Finally, I just wanted to ask a little bit more about NanoAvionics. Now, there are a few companies out there who are performing similar roles to yourselves as satellite producers and mission integrators. I wondered if you could just explain what you think makes NanoAvionics different as a business.
We do not emphasize any kind of different, let's say, piece of hardware or some particular solution of software. We always think about the end-to-end. So vertical integration, right? Customers coming to us having a perception of the satellite, of the nano satellite. He has already maybe, or at least thinks or knows where to get the payload instrument. So we offer and we start to think about the entire chain, right? From the integration, from the contract, signing the contract, then logistics, payload integration, hardware, satellite bus hardware to support that payload, then integration with the launcher, launch itself, and then operations, commissioning and operations. So where we are different, we are a supplier of the end-to-end solution. Whether this is a single mission or entire constellation. There are not too much of the examples in the industry where nano satellite constellations have been launched, but we have very, very near attempts, right, where they are almost being launched. We have quite a few of those in our portfolio. And why those customers like us, we offer them end-to-end solution. Very clear and transparent path how they will bring their payload into orbit. In general, after all, this is only the data which they get. They don't care about the launcher, they don't care about the satellite bus, etc. Well, how to say, hypothetically talking, right? Of course they care because they will pay for that. But as a final result, they get data in whichever form, in the form of image, in the form of, telecommunication transmission, I don't know, some orbital parameters if it's, scientific mission, etc. So we're always talking about end-to-end mission. How they are now here, but we're talking how they will get that data into their physical location. We're even thinking about these servers, how we will safely, transport that data from the orbit through our ground stations to their laptops. So this is what we do, and I think, and as our customers are telling, this is one of the main things which distinguish us from our customers, where the satellite bus is only a component. It's not like absolute thing or absolute thing which is solving all of the problems. No, this is the system which we're developing, entire system, entire infrastructure, like a railway, right? Even though we are selling those components and subcomponents and buses separately, but this is not our main focus. And then on top of that, customer support. Transparent customer support. We communicate a lot and we invest a lot into customer support. We want, our customer to have quite a good relationship with our staff, with engineers they support. We have, for all of the projects, we have dedicated engineering staff, project management staff, etc. It's not like, we launched or we delivered and forgot. No, we take a lot of care about the relationship with our customers. So roughly telling these two things: vertical integration of the product or the service and customer care.
Well, great. Thanks, Vytenis. That's a good place to finish up. Thank you very much for sharing your insights on agile manufacturing in the space sector. I think our listeners will have learned a lot about this and really appreciate how much goes into the process now.
Thank you, Hal, and thank you, colleagues, for listening. It was a very interesting conversation. Thank you, and best of luck to all of you.
Great, and to all our listeners out there, thank you for spending time with us this week, and I hope you enjoyed the episode. If you'd like to find out more about NanoAvionics and see further details on the company's portfolio, please go to satsearch.com for more, or click on the link in the show notes. On the satsearch platform, you can find technical details of products and services from companies around the world and request CAD models, ICTs, datasheets, quotes, introductions to businesses, or whatever else you might need for trade studies, procurement, or technical assessments. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.